Bismillahirrahmanirrahim. How are you, students? Students, this is going to be another lecture on the series of online classes for the students of class 7. Okay, in this lecture, I am going to be solving some exercise problems based on chapter 2.2, 5.3, 5.4. Okay, without further delay, let's get started. Here is our first problem. Here the buying rate means the cost price. Okay, the buying rate of a milk Vita is taka 52 per liter and the selling rate is taka 55 per liter. What is the percentage of profit? Okay, so the cost price of 1 liter of milk is taka 52 and the selling price of 1 liter of milk is taka 55. As you can see that the selling price is higher than the cost price. That means we are in profit, and you know, when this happens, the profit is selling price minus the cost price. Now in this case, the profit is taka 52 minus taka 55 minus taka 52 equals taka 3. And you know, and you all know that from our previous lecture that the profit is selling price minus cost price. I have discussed this in the previous lecture. Okay, now you know that the profit or loss, it actually depends on the cost price. Here the cost price is taka 52 and profit is 3. So for taka 52 there is a profit of 3. For taka 1 there is a profit of 3 over 52, and for taka 100 there is a profit of 3 over 52 times 100, and that is 75 over 13. Okay, this means the profit is 5 and 10/13%. Actually, and you might be wondering that why I am not using the law of finding the percentage of profit that I have introduced to you in the previous lecture. Well, don't worry, son. You can also do this as follows. You know, profit in percentage is gain over the cost price times 100. As I have discussed this method in the previous lecture. You should see that if you don't know it. Okay, now in this case the gain is taka 3 and your cost price is taka 52. So let us do this. That you see 3 over 52 times 100 is actually 75 over 13. Well, you can do this math in this way also. I consider the second one actually the easy one. Okay, now let us see the next example. Some chocolates were bought at taka 8 per piece and sold at taka 8.50 per piece, and then the profit was taka 25. The question is how many chocolates were bought? I know many of you are able to solve this problem just by looking at it. Okay, look, as the selling price is 0.5 taka higher than the cost price here, right? 8 and 8.5. So it is 0.5 taka higher than the cost price. So for one chocolate, well, this is for one chocolate, 0.5 taka higher. This is for one chocolate. That means for 2 chocolate you got taka 1. That means for 4 chocolate you got taka 2. In this way, for 50 chocolate you get taka 25. Okay, let us see this into action. This is very simple. Sorry. The cost price of one chocolate is taka 8 and the selling price of one chocolate is taka 8.50. Here the profit is selling price minus cost price is taka 0.50. Well, there is a profit of taka 0.50 for one chocolate, as you all know. So profit of taka 1 for 1 by 0.50 chocolate and profit of taka 25 for 1 by 0.50 times 25 equal to 50. Okay, well, many of you can solve this just by looking at it. Well, you should do this one like this if this question hits into your question paper. Now students, here are your 50 chocolates, and do not forget to give me my share. Okay, now let us see some rather complicated problem. I think this one is complicated because in this problem actually that man bought 8 amlokis but he did not sold 6 amlokis. Okay, the cost price of 8 amloki is taka 5 if 6 amloki is sold. Okay, he actually bought 8 amloki but he sold 6 amloki. Okay, then what is the percentage of profit or loss? Well, as he did not sold as many as he bought, we need to think on the cost price of 1 amloki and selling price of 1 amloki, then we will compare them. So let us see this into action. Okay, cost price of 8 amloki is taka 5 cost price of 1 amloki is taka 5 over 8. We are dealing with cost price of 1 amloki because the problem is rather difficult actually. He did not sold 8 amlokis. That is why we need to deal with cost price of 1 amloki. In a similar way, we need to deal with the selling price of 1 amloki. Well, selling price of 6 amloki is 5 and selling price of 1 amloki is 5 over 6. And you can see that the cost price of 1 amloki is 5 over 8 and the selling price of 1 amloki is 5 over 6. The selling price in this case is higher than the cost price, so there is a profit, and that profit is selling price minus cost price. That means in that case selling price is 5 over 6 and the cost price is 5 over 8. So 5 over 6 minus 5 over 8 equals to 5 over 24. Okay, now profit or loss actually depends on the cost price. So that profit 5 over 24 actually it depends on 5 over 8, as that one is the cost price. So there is a profit of taka 5 over 24 for 5 over 8. That means taka 5 over 8 there is a profit of 5 over 24. In a similar way, for taka 100 there is a profit of 5 over 24 times 8 over 5 times 100. That means 100 over 3. Okay, now let us see this problem into another method, the easy method I have introduced it to you in the previous lecture. Let us see. Well, profit in percentage, that means gain over the cost price times 100. By the way, either of the processes actually that leads you to the same answer. You can see that taka 100 over 3 is going to be obtained here again. So in that case, the gain is 5 over 24 and you can see that the cost price is 5 over 8. So we will divide 5 over 24 over the cost price, that means 5 over 8. So let us see that you see that 5 over 24 divided by 5 over 8 times 100, and that means 5 over 24 times 8 over 5 times 100, then means taka 100 over 3 or taka 33 and 1/3. That means there is a profit of 33 and 1/3%. Okay, you can do either of the methods, the first method or the second method. Okay, let us go for the next slide. Students, in this slide we will have a rather big problem and we will solve this one in two different ways. One in the big way and the other one is the small way. Let us see the big way first. Let us see the problem first. If the selling price of a watch is taka 625, there is a loss of 10%. Or this is statement 1. What would be the price of the watch if a profit of 10% is to be gained by selling it? Well, there are two statements, right? Okay, in the big way, we will divide our problem into two different lines. Here in the first line, we have a loss of 10% and the selling price is given. So we will find the cost price from the first line and we will use that cost price in the second line to get the selling price from the second line. Okay, and we actually need to find the selling price, the price at which we must sell our price to get a 10% profit. So we need to find the selling price from the second statement. Okay, so students, let us see this into action. Okay, in the first statement there is a loss of 10%. Well, that means if the cost price is taka 100, then the selling price is taka 90. Okay, you all know that the loss of 10% means cost price 100, then selling price 90. Okay, so when the selling price is taka 90, then the cost price is taka 100. As we are given in the first line, our selling price is 625, then we need to find the cost price. That is why I have rewritten that previous line in this way: selling price 90, cost price 100. What if selling price 1, then the cost price would be 100 over 90. Then our selling price is given, you can see that 625, then our cost price is 100 over 90 times 625 is equals to taka 6250 over 9. Well, remember that line, 6250 over, no, actually do not remember that line. I want you to write down in your copy and see the lecture. Okay, write it down and see, and then if you will get it interesting, otherwise it will be very boring. So let us go to the next slide, and in the next slide I will be dealing with the second line. what would be the price of the watch if a profit of 10% is to be gained by selling it. Okay. From the second line, there is a profit of 10%. Well, that means if the cost price is 100, then the selling price is 110. This is easy to understand. Profit of 10% means 100 to 110. And from the first line, we actually have our cost price 6250 over what it was actually over 8. Okay, let us see what it is. So when the cost price is taka 100, then the selling price is 110. When the cost price is taka 1, then the selling price is 110 over 100. Then if the cost price is 6250 over 9, we actually found that 6250 over 9 in our previous slide from the first line. Okay, then the selling price is 110 over 100 times 6250 over 9, and this takes you to taka 763 and 8/9. Okay. Now, as you have solved this problem in this big way, I want you to solve this in another different way. Well, this one actually includes one of your example problems. That is why I have solved this in two different ways. So let us see the second one, and you will find it very interesting. Suppose the cost price of that object is taka 100 and you have sold it at taka 90. Okay, 10% loss. Okay, now what actually you need to do, you actually need to sell that thing at 10% profit. That means of taka 100 you need to go to taka 110. Okay, 110. That means in that case, suppose the cost price of the watch is taka 100, then at 10% loss, the selling price is taka 90. What happens at 10% profit, that the selling price is taka 110? We need to sell our product at 10% profit. Okay, well, that means there must be some kind of way from 90 to 110. That means we need to go from 90 to 110 to get our desired result. Okay, so instead of taka 90, the selling price should be taka 110. Instead of taka 1, the selling price should be 110 over 90. But the selling price in our problem, actually it was given 625. That means instead of taka 625, the selling price should be 110 over 90 times 625. And it is also 6875 over 9. Okay, as you can see, actually these are the both of them actually leads you to the same result, 6875 over 9. Okay, I think you find the second one interesting as it is very short, 1 2 3 3 3 6 lines, very simple. By the way, you do not need to draw this animation 190 110. This is for the better clarification to you. Okay, so let us see the next one. Well, in this slide I have introduced a big problem, but I promise you the solution would not be big. But that problem looks big, actually this is not big. Well, Mr. Nelim is a service holder. His monthly basic pay is 22,250. Okay. The income tax of 2,50,000 taka of first slab of annual income is taka 0. That means, say if you are an government employer and if you earn 2,50,000 taka in a year, then you do not need to pay any taxes. But if you earn more than 2,50,000, then you need to pay taxes. What this line actually telling you, the income tax of first 2,50,000 taka of the first slab of annual income is 0 taka, and the rate of income tax of the next annual income slab is taka 10. That means for the extra amount over 2,50,000, you need to give tax at a rate of 10. Okay, that means in 100 taka you need to give taka 10 to the government. Then how many taka does he have to pay as tax? This is the question. Don't get scared, well, because this problem actually looks big. You see that we know 1 year is 12 months. The means 1 month basic pay is 22,250. Means 12 month basic pay is 2,67,000. Okay, but you know that for 2,50,000 taka you do not need to pay any taxes. So actually you need to pay taxes. That means 2,67,000 minus 2,50,000 equals to 17,000. Well, on 17,000 actually you need to pay taxes, right? and the tax rate is taka 10. That means for taka 100 there is a tax of taka 10, and what you need to find that for taka, well, that 17,000, what is the tax? For taka 1 there is a tax of 10 over 100, and for taka 17,000 there is a tax of taka 1700. That's so simple. Okay, the problem ends here. Well, I told you that problem actually looks bigger than it is not big, so don't get scared at the big figure. Let us solve the most important problem of profit and loss. And hold tight, this one is one of my favorite problems, and you will see why this one is my favorite problem in a minute. So hold tight. If an object is sold at taka 400, then there is a loss. Okay, there is a loss. Again, when the object is sold at taka 480, then there is a profit, and that profit amounts to 3 times the loss when sold at taka 400. Okay. What is the cost price of the object? Now stick with me, it will be very easier, and I think this is a very important problem for your exam also. So here from the first statement, well, you can see that there are actually two selling prices. Taka 400 is one selling price and taka 480 is another selling price. Okay. Suppose when you sell that thing at taka 400, there is a loss of taka x. Okay, because the first statement is telling us if an object is sold at taka 400, then there is a loss. We assumed that the loss is taka x. Now remember that when there is a loss, well, you are selling your product at a lower price from your cost price. So in that case, cost price is greater than the selling price and you are having a loss. So the loss must be cost price minus selling price. Now if you take selling price on your left, then cost price would be selling price plus the loss. So in that case, on your left, the cost price should be selling price plus x. Okay, your selling price is 400 and your loss is taka x. If you add them up, then you will get your cost price. So simple. Let us see the second statement. Okay, from the second statement, well, there is actually another selling price and it is 480. In that case, you tell me what is the profit? Well, profit amounts to 3 times the loss when sold at taka 400. Well, you had a loss of taka x when you sold that item into market. Okay, now this time the profit is 3 times the loss. So in that case, the profit would be 3x, and you all know when you are in profit, that means the selling price is greater than the cost price, and in that case profit equals to selling price minus the cost price. And if you take if you take the cost price on your left, then profit plus cost price equals to the selling price, and that means the cost price is selling price minus the profit. So on your left, the cost price should be selling price 2 minus 3x. See if you understand it. I told you this one is one of my favorite problems, and this is very important for your exam too. So what we have in this slide, actually we have two equations. So let us write those two equations in the next page. Okay, sorry. So as you can see from those two equations, both of them has cost price on their left. On equation 1 we have cost price in our left, on equation 2 we have cost price on our left, and those cost price are same. That is why we need we can have those right hand sides equal. Okay, so selling from price 1 plus x equals to selling price 2 minus 3x. Now let us substitute those values. The values of selling price 1 is 400, you remember that, and selling price 2 is 480 from the problem itself. So it is 400 plus x equals 480 minus 3x. I actually did not do anything. I just substituted the values. Don't make it complicated. Do it as I have solved here. Okay. So by simplifying this, I get x equals to 20. And what is x? Well, x is actually the loss when we sold our product at taka 400. Okay, now our question was to find the cost price. So the cost price from equation 1, see above the equation 1, selling price 1 plus x. If I add that x with selling price 1, and selling price 1 is 400, then I'm going to get my cost price. So my cost price is 400 plus 20 is taka 420. Okay. Okay, this problem ends here, and students, this is one of my favorite problems. I suggest you to do. By the way, I have one more suggestion for you. I think you are watching my lectures one time. I want you to see at least 3 times. At least 3 times. If you do not see them at least 3 times, you will not get them, because it's a I have made your lectures in PowerPoint slides. So in a single lecture there are many contents, so it is not sufficient for you to see them once. I want you to see them 3 or 4 times, then it would be easier to you. Otherwise you will be in trouble. Okay, let us see homeworks. Well, I have prepared this homework for you. Actually, a tradesman allows a discount of 15% on the written price. How much above the cost price must he mark his goods to gain a 19%? Okay, if you can solve this problem, you can actually help your father. If your father owns a business, okay, you can help your father with this problem. It's a very practical problem. Okay, well, there is actually this is very important. If you can solve this one, you understand profit and loss. And there is also a suggestion. I suggest you to solve all your example problems before solving this problem. And this ends chapter 2.2. I have solved a couple of problems in the previous lecture. I have solved many problems in this lecture. Actually, I think I have solved 11 to 12 problems among 15 problems of your exercise, and number 1 and 2, exercise number 1 and 2, they are very easy to solve. That is why I did not show them. So if you find any difficulty in solving the exercise problems, although I have solved many of them, then immediately you should let me know. Then let us see how, if I can fix them or not. So let's jump forward to our next chapter, and it is 5.3 part 2. You know, we can factorize algebraic expressions in many ways. I have introduced you 3 popular ways: factorizing using common factors, factorizing by regrouping terms, and factorizing by identities. I have actually explained those 3 one by one in my previous lecture, so I'm not going to illustrate them, but I'm going to apply them to solve these 5 problems. Okay, so let us see them. So this is one. I need to resolve it into factor: a squared plus 3a minus 40. As you can see, well, this a square plus 3a minus 40 is actually fits into an identity, as after a square we have a positive sign. That means x square plus a plus b times x plus ab, that one. X square plus, after x square we have a plus sign, and after a square we have a plus sign, so we must go with that one, and that one is x plus a, x plus b. So let us see this. As you can see, 3 can be written as 8 plus minus 5. That means 8 minus 5 is 3, and 40 can be written as 8 times minus 5. It is minus 40. So you can see that this line fits into the identity of x plus a, x plus b, with a 8 and b minus 5. So it is a plus 8 and a minus 5. Okay, it is done. Let us go for the second one. Well, you just see that the second problem is identical to the first problem. If I multiply the first problem by 2, then I'm going to get that one. Okay, so what I want you to know, that you must have that a square term free from any coefficient. I mean, you need to free that by this way. By taking out 2, we have that a square plus 3a minus 40. You cannot apply that identity, well, this identity, with 2a square. You need to make that a square free of coefficients. Okay, free of coefficients means the coefficient must be 1, because in the equation x square plus a plus b times x, the coefficient of x square is itself is 1. So as I have solved it, it is 2 times a plus 8 a minus 5. You see, those 2 problems are similar. The reason I have introduced those 2, that 2a square. Okay, so let us see our next problem, and the next problem is a squared minus b squared plus 2bc minus c squared. Okay, as you can see, I have taken out the minus sign, minus common, and minus b square minus 2bc, and that minus actually takes into a positive form, plus c square. And you all see that the second term, it actually fits into that identity a minus b squared equals to a squared minus 2ab plus b squared. So this can be written in this way. Well, that is, this one fits into another identity of a squared minus b squared, that is a plus b into a minus b. That means a plus b minus c, a minus b plus c. Okay, this is also solved. Let us see the next one. Well, this lecture is very quick, I know, but I have nothing to do because these problems are so simple. Okay, this one actually it was your homework, right? Let us solve this one. So 16x to the power 4 can be written as 4x squared whole squared minus 9y squared whole squared, and this one fits into the identity a squared minus b squared. So let us write it as it is. You can see that the first term cannot be further reduced, but the second term can. Okay, as 4x squared can be written as 2x whole squared minus, and 9y squared can be written as 3y whole squared. Now this is again fits into the identity of a squared minus b squared. So let us put it 2x plus 3y, 2x minus 3y, and hence this ends your problem. You see that 5.3 is so simple. Let us solve the final problem of 5.3. I want you to pause that video and solve this problem by your own. Or if you can't solve this by your own, then you are practicing a lot less, I think, because to be a master of 5.3, what you need to do is to practice. There is no other alternative way of mastering 5.3 other than practicing. Okay, so let us see this. You can see the first three terms. Okay, 4x squared, it is a perfect square. 9y squared, it is also a perfect square. That means it fits into the identity a plus b whole square, the first three terms. So let us write this as it is. 2x whole squared, that means 4x squared. 2 times 2x times 3y, that means 12xy, and plus 3y whole squared. And 16a squared is written as 4a whole squared. From the first three terms, I got a plus b whole squared minus 4a squared. And again you can see there is another, this one fits into that identity. We should apply that one. 2x plus 3y plus 4a, 2x plus 3y minus 4a. And this is the final result of this problem. And here are some homeworks for you. 1, 2, 3. Okay, solve these three, and I think you can solve these three by your own. Well, this ends chapter 5.3. By the way, students, if you find any difficulty while solving 5.3, you can ask me for it. You can ask your friends, or what you can do, you can email me. I'm going to post the email address in the video description box or in the about section of my YouTube channel. So you can email me also. Okay, your homeworks. Or if you do not want to do all of this, what you can do, after 3 or 4 days, I'm going to upload the PDF version of 5.3 in this video lecture. Okay, in the description of this video lecture, you scroll down the video and then you will get the link for the PDF version of 5.3. Do not ask me for this. Okay, so let us start chapter 5.4. By start means let us solve some problems, as I have already discussed 5.4. Okay, well, this is actually a creative question. I have taken this directly from your book of 5.4. Here a and b are given. You need to determine the value of a plus b, and you need to determine the value of a squared by using a formula, and you need to determine the product ab by formula. Okay, and in the third one you just need to put x equals to 2 for ab. Okay, so let us solve a plus b. Well, this is a problem of class I think class 4 students can actually solve this one, 4 or 5. This is nothing but an addition. A plus b, that is 4x plus 2. Okay, let us go for the second one. It is a squared, and a is 2x minus 3, and in this case 2x minus 3 whole squared. That means a minus b whole squared, a squared minus 2ab plus b squared. Let us apply this. You can see a squared minus 2 times a times b plus 3 squared or b squared. And this takes you to 4x squared minus 12x plus 9. That's very simple. And the third one is also very simple. Determine the product of AB by using a formula. Well, they actually add by using a formula. Keep this in mind. Okay, here is our third problem. AB given, and AB is 2x minus 3, 2x plus 5, and they want us to solve this by using a formula. And let us use formula 2x plus in a bracket minus 3 and 2x plus 5. That means x plus a, x plus b. I'm treating 2x as x and a as minus 3, b as 5. X plus a, x plus b, that means x squared plus a plus b times x plus ab, right? Remember that. Then x squared means 2x whole squared plus a plus b means minus 3 plus 5. A plus b times x, here x is 2x plus a times b. Okay, you see that? Very simple. Okay, now 2x whole squared means 4x squared, and then 5 minus 3 is 2, 2 2s are 4x, and 3/5 are minus 15. So AB is done, and you need to put the x equals to 2 in that expression. So at x equals to 2, AB equals to 4 times 2 squared plus 4 times 2 minus 15, and it is 9. So AB equals to 9. I think this is the most simplest math of all of this book, that creative question. I don't know how did I take that one. Okay, so let us see the second one. Well, I actually assigned this one as a homework in the previous lecture. So this one is quite interesting, but this one is also easy. So resolve the second expression into factors. Okay, let us resolve this second expression into factors. Here is our given expression, x squared plus 3x minus 10. And you can see after x squared we have a positive sign. That means x squared plus a plus b times x plus ab. Okay, x squared plus 5 plus minus 2 times x plus 5 times minus 2. And this is x plus a, x plus b, that is x plus 5 and x plus bracket minus 2, or you can write directly x minus 2. Okay, those of you are understanding slowly, you should write that last line. The third line must be omitted. It is very lazy. Do not need to write that one. Okay, now in the second question, determine the HCF of the two expressions. This one seems nice. So let us resolve the second expression into factors first. Okay, here is our second expression, and you can see that second expression can be rewritten as x squared whole squared minus 25 whole squared, because 25 squared is 625, and this one actually fits into the identity a squared minus b squared. That is why a plus b, a minus b. In the second term, x squared minus 25, it can be further reduced as 25 can be expressed as 5 squared. So let us write it as it is. X squared minus 5 squared, that means x plus 5, x minus 5. And you know, the second expression is x squared plus 3x minus 10, and we have factored that in question number A, and the result is x plus 5, x minus 2. And they need us to find the HCF. You know, HCF is the common factor, right? Common factor of the expressions. And in the first expression, you see that x plus 5 is there, and x plus 5 is also there, so we need to take x plus 5 as our common factor. Okay, the HCF is x plus 5. You see, that's simple. Let us go for the third question. Okay, here is the first expression, x squared x to the power 4 minus 625. As you know, in question B we have actually resolved this one into factor as it is, and the second expression I have factored it in question A. So let us find the LCM. Keep your attention here. Well, highest power of all possible factors, the product of the highest power of all possible factors is your LCM. In order to be LCM, your factors must not be common. Okay? So in the first expression, the first factor is x squared plus 25. Well, x squared plus 25 is absent in the second expression, but well, it does not matter if it is present or absent in the second expression. We need to take it. X plus 5 is common. Okay, we need to take it. X minus 5 is not common in the second expression. Rather, we need to take it because it is not HCF, it is LCM. We need to take highest power of all possible factors. I marked all by a circle. Okay, you need to take all the factors. You need to take x minus 2 also, because x minus 2 is there in the second expression but not in the first expression. Well, it doesn't matter if it happens to be in the first expression or not. You need to take all of them while finding LCM. Okay, this is the LCM Well, it is the answer, but let us reduce that one. You can see that x plus 5, x minus 5 can be written as x square minus 25, and there is x minus 2. And from the first two terms, x square plus 25, x square minus 25, this is actually x to the power 4 minus 625 and x minus 2. This is the final result of the LCM of our problem. So simple, right? So, okay, creative questions are done. Let us solve some quiz questions. What is the least common multiple of a squared, and a plus b? Here are your options. Okay, you can see that a square, a, in that three terms, a square is the LCM, and a plus b is absent in the first and second expression. So you might be wondering that the answer is a or b. No. Well, you are not finding HCF, you are finding LCMs. You need to take all the factors. Okay, the highest power of a is here a square, and a plus b is a factor, so we need to take a square times a plus b. In that case, D is the right answer. Okay, let us see another problem. By the way, I have taken all the problems from your textbooks. Okay, here are two algebraic expressions, and the first question is which of the following is the resolved factor form of the first expression? Okay, let us, the first expression is x cubed y minus xy cubed. Let us factor this out. Let us take out xy, then it is x squared minus y squared. That means the option D is your correct answer, xy, x plus y, x minus y. Okay, let us see the second question. Which one is the HCF of the two expressions? Okay, here are our expressions. The first expression, I have written the factor form of the first expression, and the second expression. As you can see, in both of the expressions, x minus y is the only common factor. That is why in that case B is the right answer. Okay, which one of the following is the LCM of the two expressions? From the previous problem, you see the expressions. Okay, the expressions are xy times x plus y, x minus y, and the second expression is x minus y, x plus 2y. Well, in order to be LCM, it does not matter if your factor is common to two or more expressions or not. You do not need to have common factors. Okay, that means for xy, you need to take xy, x plus y, it should also be included, x minus y, x minus y. X minus y is present in both the expressions, so we need to take one, and x plus y is present in second but not in first. Well, it doesn't matter if it happens to be in the first expression, we need to take that one also. Okay, here is your LCM, xy times x plus y, x minus y, and x plus 2y. And you can see that x plus y and x minus y can be written as x squared minus y squared. So in that case, option C is the correct answer. This is the last quiz question. What is the HCF of 2a and 3b? Okay, you can see there is actually no common factor in between 2a and 3b rather than 1. So 1 is the correct answer in that case. Okay students, here are some homeworks for you. I want you to solve these homeworks by your own without the help of any solution book. And as our lecture have finished, well, I have some suggestions for you. Students, lecture 5, well, this is lecture 6. Lecture 5 is, I have completed lecture 5 on chapter 9.3 and 9.1. Okay, so lecture 5 is rather complicated than any other of my lectures. Okay, so I want you to see lecture 5 more than 5 times, and after watching lecture 3 and lecture 5 times, you need to solve your example questions, and then after you have done, you need to solve the homeworks of lecture 5 and lecture 6, and then go for the exercise questions, and you will find many of them solved here. And if you face any difficulty while solving any of the exercise questions in your textbook, you should immediately let me know. I will try to upload the PDF version on the video description link. I hope you enjoyed this lecture, son. Thank you very much.